Hello everyone and welcome to the Engineers Project YouTube channel, and today we are going to do a development board based on ESP8266, that is NodeMCU. Okay, we are going to do this board in a quick way, in a best way, and it's a technical subject whereby we are going to use Skype EDA to do the design. At my interface, you can see this is my KiCad EDM, and therefore you are going to get started as quick as possible. You come to new file here, you open project like that, then you want to save it to where we had saved other projects, so you go to articles. I like saving my projects here, new, and I'm going to create a new folder here and name it NodeMCU, and then it's an ESP8266 board. Okay, I'm going to open it. Then I'm going to save now my schematic, which is NodeMCU. Save it like that. Then we get started at the schematic. This is where we're going to place our schematic, and here we'll begin with our first component. Hit A to place your first component. Okay, do not ask again. Okay, let it load. We want to start by creating our first components with the schematic here, and from the look of things, we're going to do it in the best way possible. Let me try to connect my phone to the charger so that it can help me do this thing. So our first component here we're going to place is the USB port. We want to start by using our USB serial communication unit. So this will be our first circuit, USB serial communication unit. Let me reduce this one. Okay, so you can have it here. So for component for the USB serial communication unit is the first circuit we are going to do, and we are going to start with the USB port. So it has fiber. USB port B mini micro. Okay, you can use this one. So for this one you can click OK and place it somewhere there. Okay, you can place another component which is ground G and B. So like that, place it there. And place another component which is resistor. I will use resistor small, imperial symbol. I can rotate it. So it is at pin 2 and pin 3. Pin 2 and pin 3. Pin 2 and pin 3 will be having resistor of the same. So pin 2 and pin 3 here, can edit value. This is 22 R 22 R. Okay, then you can copy this one and place it at point number 2 here. Can move the label, move R like that first. I do the settings, so I can move these labels to this point. I can move this one again, this one to that point. Then I can move this one. I can move this one to above, somewhere there. Then move this one again to that point. Control C. So I can wire these W for wire. Okay, like that. Or this one, or this one to that point. Somewhere there. Okay, Control C. Pin number 4 has nothing, so it's cancelled like that. Pin number 1 has a diode which is IN58, second place symbol. Then I go to diode, I can search it IN directly 58. Not IN but 1N 58 19 diode. This is the diode that they have used. So okay, I can rotate it for alpha rotation like that. There. Then I can select all these and move it a little bit down to such a point. I can place another component which is now V in. First, so I can go for P for power, then set V in, start resisting. Okay, so you have an input power there. Okay, I can create a symbol, a quick symbol for that. So I can come here like this, create a quick symbol. Okay. Then I can search my own library here where I can input that symbol. Like that. Come. So let me try to go to power. Power here. Okay. For power. The symbol should be V in. Okay. Not a must. Symbol name I can just name it. I can just leave it like that. Just name it V in. No. VWR. Okay. Move. Can come here and move this. Move. Then I can reduce it. Then I can come here and pick this and draw like this. Not like that. I can come here and draw like this. Then I come to pin. Before I can still come back here. Then I can come to pin. Control 7. Then I can Control 7. Then I can come back here. Okay, here. And place the symbol, which is here. I did not have permission to write on that library, so I can come back here and create my own library. This one, and add it as power. I can rename this, and I can name it PWRV in, like that. Okay, and I can pick it global. Yes, cannot create laboratory. Okay. M global project. So I can come to preferences and the libraries. Okay, you can come here, search this one out. Pen. Okay. Okay, my pen added, so I can come back here and try to see whether we have it. Okay, symbol. Here we go. Okay, no problem. I can add this one, I can use this one there, then value. I can come to value, edit E, this one, and refuse to show it. Then this one will show V in, show it, then don't show. Okay, this one move. Place it somewhere there. So this one is correct. Wire. That. Control save. So we are going on very well. So we want to label, and before we label, we want to place another component. So this component is CH340CH. Okay, 340G, 340G. So this component here, okay, place it somewhere there. Two goes to UD plus. So I can move these a bit. Two goes to. So why? That, then this comes to you're good to go there. But I can still do it in a better way. I can decide to interchange this one like that for it to look better. Then I can come here and pick the labels like that. This one a label RD class, RD plus, yep. Then this one I can label RD minus bold. Edit bold. Okay. Control save. So we are good to go there. So we are done with the connection of the input port. So you can proceed to the rest. Now we want to make sure that we power. So number 1 powered RxD to V3 and ground powered. So you look at V3, it's here. Ground is here. Do you have any other ground? V3. VCC, V3, VCC. So let me do XI and XO. That one is better, it's simple. This one can do it. So we can have resistor. So first we copy this, then we move it somewhere there. Then I can edit the value. So resistor is 1 megabyte, 1M, like that. Okay. We can move to. I can move it a bit again to somewhere at that point. Can have another component A. And this component now is the crystal quartz. It's the crystal quartz. So let me see crystal quartz. But I can look for crystal quartz more like this. Okay. It comes to this point here. I can try to edit the value. We see its value is 12 megahertz. Okay. The next component we're going to do in this system is we have a capacitor. We have not placed capacitor, so we can place a capacitor right now. So capacitor, but small. NodeMCU is small. Like this. So we're going to have like 2 of them. So you can move these. You can move these. You can move. Okay. To such a point. You can edit the value to 22p. 22p. It's not capital P. This one is capital P. So I can create OK. Copy. We move to that point there. So we have it at that point. We can copy this ground again, bring it somewhere there. So to wire it. So we wire W. So it goes to pin number 7. From here, straight. From here, straight. this dance this one, this dance this one, this dance this one, this dance this one. Move. Control save. That one is good to go. I think you've done everything right. Let's proceed to the next bench. Now we need to RTS. Where is RTS? RTS is here, number 14, and DTR. So I'll give them a label. This label like this. Then we'll call it RTS. Okay. Rotation. Place it at the point for RTS. I'll copy. Move it to this. Edit. And call it DTR. DTR. Control save. Like that. So V3, where is V3? V3 goes to a capacitor. So you have to place a capacitor here. Copy. Rotate R. Wire. It goes like that to that point. Then from V3 it goes to ground. Ground is here. And I want to, so you can move like this. Control save. Now from one, in between one and that capacitor, in between one pin 16, drag G, 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 Control C. So we have this, but here we need another capacitor. Copy this, bring here, and then we can edit this. This one has no value, so it remains up, small. Okay, but this one has a value, so I can edit this, which is 100 nanofarad. Move. Wire from there to this point, from this point to that point. Control save. Now, and these, all these, this is what makes our USB serial connector, but I still want to input the final bit of it. And under this final bit, we'll have components like this. We'll have VJT, we have such. Okay, can we write long Y to have it like this? We'll have another one again, VJT, but this one now is different. Okay, I can try to look at NPN. Then now I look for PNP. Yep. Okay. Long way. So there, like that. Then we shall be having resistor R. This time, this one I'll be using the American symbol resistor. But now I'll use the American symbol, US symbol small, like that. Rotate R, place it somewhere like that, can expand it. Okay, I can copy, place it again somewhere there, like the other one. There. What else do I need? I need to wire it, I don't need any other component. So I can wire W, like that, wire, yes, like that. Then, there is something new here. You do some of these. Oh, it has picked the wrong place. It picks the correct place like that. Okay, we can extend. Oh, sorry. We can have another one, and we can create another joint here, like that. Then I can copy this one. Copy this one to come and join here. Then I can copy this one again to come and join here. What else do I need? So I need a NR set. So I need this one here. I need another one here. With that, okay, with that one, I'll be forced to value like that. So I can edit here. Then I can hide this one. Okay, I'll edit this one. And we can hide this one. Okay, like that. So I'll have a label here. This label is called NR reset, NRST, like that. Okay, I can rotate it like this and place it there. I can copy the label and place it somewhere there. Then I can edit it. We're editing and name it GPIO0. GPIO0. Then I hit OK. Control save. So we are almost there. Control save. So this one, I will be naming it. Okay. So I have this one. Okay, this one. can try to demarcate the borders for this one so that I can give it the name. So I can come here, view, plus text. This one I can name it. That's the USB serial communication. USB serial communication unit. Bold. Okay. Can edit. Text size. If we see what it looks like, edit. Okay, 2.5. So I can use around 4 millimeters. Then I can move. So that's the first bit of our schematic. We go to the second bit of this system building. And the second bit is the flash memory. So I can still place a symbol, then we place look for flash, then you go to memory. I want to look for a better flash. So our memory will have a CS, it will have VCC, it will have ground. That's around 8 pins. So this one is 0 to 8 here. It has ground, VCC, CS. Okay, this one has 8 pins. It has SCK. It has WP. There's the W. Yes, it has the WP. It has the CS. SCK. Clock. Hold. What is here? Okay, let's have a look at the utilize this one. Okay, we have this one like this. So pin number one is SD command. SD command, so you can come here and put the label SD. It first comes SD. We'll use underscore CMD. Like that. Then move to pin number one. Okay, move Pin number 2, SD D0. Copy this one. Okay, copy this one. Move here, rotate. Then the edit. SD D0. Okay. Pin number 3, SD3. Copy. Move it here. Edit. SD underscore 03. Okay, not 03 but D3. Like that. Move to pin number 4. Number 4 is ground. Okay. G and D. Okay. Wire. Connect. Control save. Pin number 5. SD1. SD1. So you can copy this. Place at pin number 5 and then edit. SD D1. Okay. Go to pin number 6. Number 6 is SD SEK. Number 6, so you can copy. Place here. And you go to edit. SD underscore SEK. Okay. Pin number 7. Pin number 7. Pin number 7. Where is number 7? SDD2. Copy. Place one. Edit. SD. Let's go D2. SDD2. Okay. Then now pin number 8. I have to place a component which is 3v3. 3v3. Okay. Control save. Now this is maybe the flash. The flash, I think it's done. So you can put the level here. Control save. Okay, let's go to the next bit. Now our next bit. We want to try and do the input peripherals. Now before I do the input peripherals, let me first deal with the ESP itself. So it's an ESP8266. ESP8266. Well, how many pins does it have? It has pin number 1 to pin number 33. Okay, let me look at this. Let me just place it here. Still move. Yes. So very quickly we start with pin number 1. What is in pin number 1? Pin number 1, pin number 4, pin number 3 joined together. So why? Pin number 1, pin number 4. Pin number 1 goes to pin number 4. Pin number 1 goes to pin number 4. Correct. Wire W. Like this. You take it there. Then like that. Then pin number 3 again. There. Like that. Then now here you place power. You pick 3V3. Like that, okay. You connect it there. Like this. No, sorry. You pick wire and you join it there. Control C. So pin number 1, 3, 4. That one is complete. Pin number 2. So when I can edit this, then this one they're trying to add some. Okay, you can pick something here. You can place a symbol A for pin number 2. Pin number 2, which is an inductor. So inductor, there is no small inductor, big inductor. Pin number 2 here, like that. You have a capacitor. Small, like that. Partition R there. Then you have label this. Then you put it as UFL. Okay. That wire. That point. This point. This point. Edit. Now you got it. Edit. Edit. 1.27. 1.27. Edit. 1.27. Like that. Okay. You're there. So you go on to number 3, number 4. That one is complete. Number 5. Number 5 has no work. So it's number 5. We go to number 6. Number 6 is a pin which is ADC. So a label Number 6 as ADC, like that. Okay, I can move this, and then I copy this. It's very easy to copy and to keep editing. Edit ADC. Okay, number 7 CHPD, copy, edit CHPD. Okay, number 8. Let's look for pin number 8. 7. Number 8. Where is number 8? Number 9 is here. Okay, number 8 is here. Number 8. GPIO 16. Copy. Place it here. Edit. Edit. GPIO 16. Enter. Number 9. GPIO 14. Copy. This is number 9. Edit. GPIO 14. Enter. Control save. Okay, number 10 GPIO 12. Copy. Take it to number 10. Edit. GPIO 12. Okay. Number 14. Number 11. VDD3V3. Now let's go back to these pins. Pin 1 here. So I can copy this, rotate R, check it to pin number 11, pin 11, rotation R, wire, place it there. Pin number 12, GPI 013. Number 12 was number 12. Here, copy. Copy. Take it here. Edit. GPI 013. GPIO 13. Number 13. Is number 13. See, number 13. GPIO 15. Copy. Edit. GPIO 15. GPIO 15. Enter. Number 14. GPIO 02. Copy. Edit. GPIO 14. Control C. Moving on well. Number 15. Oh, it's 15 now. 15. Edit. Copy. Move to 15. Edit. GPIO 0. And GPIO 0. Number 16. Copy. And GPIO 04. Edit. GPIO 2. to number 17. 17. So let's go here. Number 17 again. Okay. This Control C. Number 18 is D2. Number 18. Copy. Number 18. Edit is D2. 119. Copy. Edit. Yes. D3. Number 20. Number 20. CMD. Copy. Let's go to number 20. Edit. SD. D. SD. CMD. Number 21. Copy. Place here. Edit. SD. Yes. SK. Number 22. Copy. Edit. SD. 0. D0. Number 22. SD D0. Number 23. So let's go to number 23. Where is it? 24. 23 is here. Copy. Edit. SD. D1. Number 24. Copy. Let's go to GPI05. Edit. GPI05. GPI05. Number 25. 25 here. RXD0. Copy. 25. Edit. RXD0. RXD0. Number 26. Number 26. TXD0. Copy. Bring it here. Edit. TXD0. Okay. Number 27. Number 27, sasa. Number 27 and number 28. Okay, and then we copy this thing here. Without no let's copy. Okay, so we have it like that. Why? Yes, move. Then capacitor. Control save. Okay. 27, 28, 27, 28, 29, 29. Put that one connected again. Okay. 29, 30. That from 30 you go to rotation R. From there, there is that capacitor. Then copy these again. Place it somewhere there. There is another capacitor here. This one is interconnected like this. From there it goes to that one. But we have a power flag there. This power flag, copy. Place it there. Control C. You have a ground in between these. Control save. Then from here it goes to 31. So where is 31? Is here. Control save. 31, 32, and RS reset. 32, copy, like that, edit, and RST. Okay, then we go to the final pin, which is pin number 33. And pin number 33 is grounded. So A. This, okay. Wire. Control save. Okay, so then we reduce this one again. We see what we have achieved. So this is a schematic for our board. This is the schematic for our board, so I can do this, can demarcate its border like any other. Like any other system. So with this you can come here and place a text again like that, and this will now name it the ESP8266. ESP8266. Okay, you can place it somewhere there. So control save. So yeah, we're still going on nicely. Our system is coming up strongly. So the next thing we need to do is to label our pinout. And to label our pinout, we need to go for the ports now. Okay, I'm still studying the ports. Text then. So I need to label mine accordingly to how I feel is safer for me. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. Okay. Then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. I can begin by doing my first 15 pins from here. I want to add some, to label these pins, I want to connect them to ports. Therefore, I'm trying to design it the way I feel it will be safe. So, GP102, GP. Okay, pin 1 to 15. Okay, there is no any problem. I can place my first pin, which is connector con. Do this 0.1 times 15. Okay, like that. Okay. I'll move it to the next place. But this one will be moving our first pins, so I can go with it. So the first pin is the power pin. P3, so I can pin number 1. Okay. What do? I can place the component. Okay, this one here. Okay. This is our pin number 1. So I can wire it like this. That one is correct. Control save. Pin number 2 is ground. Still place a component. Okay, escape. Come for ground here. Okay, like this. Place it somewhere there. And then I can wire like that. Control save. Pin number 3 is TXD0. Look for TXD0, TXD0 copy. Rotate. Drag this. Okay, control save. Pin number 4 RXE0. Rotate sharp. Pin number 5 15 copy. 7, 12. Number 8, 14. Number 9, ground again. Copy. This one goes somewhere there. Number 10, power again. Copy. This one. Control C. Number 11, GP02. Number 11, copy, edit. GP. Edit. GP02. Number 12. GP00 copy. Number 13. GP04 copy. Number 14. 14. GP05. Number 15, GP016. So this is the first pinout. First pinout. Can go for the second and the final pinout. This one now. So I can still come like this. And then place symbol. Then it was connected with connectors like this. Then we start with pin 1. USB. So VN. So the first pin here is VN. Copy this one, then I can introduce it like that. I can place it here, wire like that. Control save. So I can try to do number 6 and number 2 there that are connected. Number 6. And number 2 there like that. Escape, and then they are grounded, so you can be grounded like this. Like that. Control save. Number 3 again are reset. Copy. Number 4 CHPD. Number 5 BDD3. Number 5 is with power. Copy. Number 6, number 7 now. Clock. Copy. Number 8. DO. Copy. Move. Number 9. Command. Yeah, copy. Number 10. D1. With D1 copy. Number 11. Number 11. D2. This copy. Rotate. Plus. Number 12. D3. Number 12. Copy. Rotate. Number 13. ESV. RESV. Okay, you can just place it here. RESV. We will know the fate of it. Edit 1.27. 1.27. Number 14 ADC. Number 14 ADC. 1.27 ADC. Number 15 AO. 15 AO. Move. So I'm going to try to copy it. Then we go with it now here. So this is the pin out, so I can put the board here. Then I can put the insert. There's a graphic. And put up a pin. control save. Okay, let me reduce this one. We see what is happening. So we still have this size to draw other things. So let's do power. We want to power this USB. So let's do some power circuits here. Okay, so you can enlarge it like this. And we start doing some power circuit here. So how do I begin with power circuit? Of course, we will do here. We'll start with this one. I can copy this here, so I can copy and I take it. At this point, like this. So that's my V in. So I'll go. I want to look for a power supply system, so I can place a symbol like this. Then I can come and say 3V3. We see what we'll get. Power protection. Power. I don't want to protect power. Switching. Okay. Okay, this is one of them. Fixed V in and VCC only, which are important. SWV out, V in, V out, only, which are very important to me. V in and V out. Let me see this one. Okay, this is all the same. Okay, you can pick this symbol. V in and V out. Like that. So we'll be having a capacitor. Copy this. Put it here. Edit. Do this. Do it small, so small. It just remain like that. You can copy it. Now on this side, I'm going to put a different type of capacitor. Okay, cup. I'm going to have cup symbol like this, but the use symbol. Okay, like that. I'm going to come this label here. I'll close this and I'll close this. Then I'm going to copy this ground and bring it somewhere there. Then I'm going to wire everything. I'm going to wire this there. Control save. So we have our power supply system. What we are going to get out here is this power here. Let me copy and bring it here. I rotate R like this. Black and white like that. Control C. So our power supply system is done. So we can put borders here. Then I can come and place a text here and label it power. Like that. And place it somewhere here. Like that. That's my power. Can control C. So to power, we want to finalize. I want to go for the bias inputs for our system. Now the biased inputs for our system. We can try to put them somewhere below here. So for the biased inputs for our system, let's start here. We're going to start with the symbol A. The first one is using the 3 volts. Okay, here. Like this. Then after that we go to capacitor. Our system was symbol like that. Then we go to LED. LED small. Like that. Rotation. Then we can mirror Y. Like that. Then we go to label this one as GP016 GP016. Okay. Edit. Come here. 1.7. Okay. Once we have this capacitor resistor copy or rotation like that. That else we have a switch button, so you have a push button here. Rotate it and you can mirror it along like that. It can be placed somewhere there. Then we have ground. Okay, we have ground as a ground like this. Okay. Ground is somewhere there. Then we have a resistor again. Copy this and place it somewhere there. Then we have now a label. You can copy this and rotate. Place it somewhere there. Then I can edit and name it N RST, which is for reset. Okay. Then I can go to wire. Control C. That's our first bias input port. We can do our second one here, which will now involve resistors copy. Copy this like that. Copy this. Place it somewhere there. Edit. And name it ADC. Enter. Copy it. Take it somewhere there. Rotate. Okay. Place it. You can edit. Name it AO. AO. And hit enter. Then you can copy ground. Copy. Place it there. Let wire. Let's go on. That one is complete. Control C. We move on to the next one. Now this one again, we are going to do another circuit here. We start with push button switch copy. Bring it to you. Rotate. Correct. Copy. Bring it this, bring it there, edit GPI01, GPI01, okay, copy ground, rotate, place it there, back here wire, let's go, Control C. Now let's go to the final bit for schematic. Here, copy, place it there. Copy resistor, place it there. Copy again, there. Copy, there. Copy, final one, there. Now wire is so by wiring the resistors. Let's see what we get. Control C. Then you come here. Let's look for capacitor so you can place a symbol here. Capacitor symbol. Okay. Rotate. There. Copy. There. Wire. Control save. Okay, yeah. GPI0. Copy. Bring it, rotate. Place it. GPI02. Copy. Rotate. Place it. GPI0CHPD. Copy, rotate, second wire, drag, drag, G. So what we do, there is a NRST. NRST, where is it? Copy this reset, rotate. Control C. Now we go to the final bit of it. Final. We have ground, copy, mirror, that is correct. Resistor, copy, place it there. DPI15, even copy, place it here. Then wire. So this is the NodeMCU schematic. It's on a finished. I can place something here. This one will represent the bias for input stroke outputs. Like that. So I can finish up this one. Save. Yes. Now this marks this end of the schematic. And what do? We can input the text here. Yeah. And this one is the node NodeMCU ESP8266 plus CH34 0G. This is my project. It's the name of my project now. I can introduce it. That's the name of our project. That's how it's called. This marks the end of our schematic. Therefore, now we're going to do some other things. I'm going to annotate the schematic. So schematic is annotated. Okay, you hit close. Then now, after annotation, we go to assigning of footprints to a schematic. Let's do it slowly. Some time. Okay, let's wait. Let's see. Okay, here now we have our capacitors here. We need to add some footprints of them. Therefore, you come here and look for capacitors. You're going to use SMD products. So SMD 0805. Then for LEDs, again still LED, use the SMD. For this diagram, I cannot look ESP. So let's go for assembly diode 0805. USB micro USB. So I'll come here to look for C connectors, then I look for USB. And then I'll search for the one with the release symbol. Yeah, this one is good. From Molex. Then we go for connector. This one. Let me look for the type of connector that is used in the node MCU. Look at them and see how they appear. So this is NodeMCU symbol. Want to see the type of pins that they are using here? You can see, so they're using this type of pins. Okay, so let's go back here and select such type of pins. In our addition for this, so they're using the pin. You can check here. So let's look at pins like this vertical. Yes, so preference. Pin 2 vertical. Let's see what they use. This actually, this is the type of the pins they used in their design. So okay, for the inductor. Again, so I can try to look at the. Let's look at them. Okay, no problem. So the type of inductor here again is I can use this one. This one I can go to package and see what is in the packages here. Check this one. This one is so big. So go on to single diodes. That one I cannot pick. SOT, yeah. This one is an SOT packet. Let's look at this one. How it looks like. Not a bad one. There is another one, but it's an SOT, so I can pick this one. Then I go back to resistor assembly 0805. Bias to low. Button switches assembly. Button switches. Let me look at the button switches that are being used on this board. Button switch. Oh my goodness, here we have them, 2 of them. So you can come back here and try to look at the button switches that have been used in the system. So let me try to check from this side. We have so many types of button switches, so I have to look for that one. Let me try to check them here. Almost that, but not that one. Of course, I'm not used to that one in the system. It's a different factory production. This one we have said no. Also, these one are from a different company. Let's have a look at them. They don't have any 3D. So from here again, it's from a different company. Let me have a look at them. They don't have any symbol. VK push button from here's another company. These are only 4 points. Okay. Could pick the last one too. Let's see whether it's having a symbol out here. DLPT. Let's check at this one. Not a bad one, but let me check out this one. Now, which type of switches is being used here? Again, you can see it again. Let me keep going until I try to get go. Panasonic. This push button is the one, but it doesn't have any. I don't know. This one is not a bad one. SPD, let me check another one here. Yes, here we go. Here it is. The same button that we need for it. So we go to this one. Let me check out its 3D printer because it's already there. Not bad one. Let me check out this one again because already it's rewarded. They want a square one. They want a square one. So I'm going to go to packages and try to check. We need a square one. That's something like this. Let me look at it from you. So let me come back here and check what type of one. No problem. So back to here. Okay, I cannot touch this one. No problem. That one is nice. There's no problem. Let me watch this. That is also nice. I have no problem with that. So this one, is it or isn't it? Is it or isn't it? Or crystal quartz? It's a crystal. So we have to view these ones again. I want to use not good at all. I want to make it a assembly. Let's have a look at this one. There's no symbol. Just 3D. Let us go back and check it. Yep. Here we go. Here we go. Let's check whether it has. Except to do the footprints. Because as per the look of things, yeah, I think it has accepted all the footprints. Okay, then we can go on now and have other things. So you can generate the net list. Generate the net list. Okay, then we can move to this side like that. Then we need to update the net list. Update the 0 errors. Close like that. You can view it here. Where is it? 3D viewer. Okay. R8, R9. There is an error from R8, R9. Okay, there's an error somewhere. So you can come back here. And go back to footprints. Resistors. Addition of footprints from resistors. Now I can add the same. Still R0 from R6. So is the resistor. Zero 0805. So So this is reason Q1. I want to change it. I should change this Q1. So let me go back again here. Q1. So let's go back to schematic. Q1, where is Q1? Q1. This is package TOSOT. Then this is ATPR. Something should be appearing for that. So yes, so generate netlist, generate, save, go back here, create netlist, update, close. Let's view. We're making sure that all components are in good term. Yeah, I think these components are in good sizes that we need for our board. Okay. Move. 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 Rotate. Rotate. Now, can have a look at NodeMCU. We'll do the arrangement. Do the arrangement of this board. Let's start viewing again. Okay. So here we are going to add some new footprints here. Let's load. We want to add mounting hole. Mounting hole 2.2, 2.5 foot pad. Like that. Okay. Okay, let's review again. We see what's going on. Okay. The board is taking shape slowly and slowly. So let me do some board settings here. I want to add some board setups here. Some of the things that we're not doing for long, so I want to add, reduce 4 layers back to back. And this one, I'll name it PWR. And this one, I'll name it GND. Okay. Look at this one here. We have wanted this PWR and P. So this one will make our PCB board be a 4-layer PCB board. Yes, therefore we can go on and on and on and try to arrange our components now. It's very easy for us to route our board. So we can try to. We want to move our component very fast to move. Second view it, let's see how it looks like. Okay, not a bad one, not a bad idea. Let's go back here and see what is not going on. Okay, let's go back here. Footprints, where is it? We'll keep changing, adjusting a board until we get to the correct board, what we need. So, let's still move on. So Q, is Q1 and Q2. Q1 and Q2. The packages. It's so big. So big. So big. Some are small. So I can change this one. Okay. Let's click. Then you come to generate net list. Generate. Save. BO. Oh no, I don't need BO right now. Like that. Update. Close. Let's view. Yes, now you're moving now well. Yes, now this one is better. Now for the crystal oscillators, let's check again. Let's go back to footprints. For the crystal oscillators, you must be having something small. Okay, take a look. Try to see whether you have something small in the crystal oscillator. and use instead of course we can use resonators. This. Let's look at this. Oh, wow. Okay, like this. Yep. Let's generate net list and row it. Okay, like this. Net list. Close. View. Again, oh, yeah, we are in the right direction now. No, I can agree now. Cannot agree anymore. Now, I need to add the footprints I had added here. They got disappeared when I went to correct on the other side. So I added them there. And I added another one here. Then another one on this side. Let's watch it and see what you're getting. The 3D viewer. Yeah. It's taking shape, it's taking shape, it's taking shape. At a faster speed. So you can move this one to this point. So what I need to do is to bring this one here, move. Then move. Then I can view. The distance is not the same, so I can move this one. I can view. Wow, it's taking shape. Now we can start arranging again these ones. So we can move this one, move. Move this one, move. move. So let's view the final arrangement. We see how it looks like. Okay, let's reduce this one so that we can copy all these and then move them, all of them now closer to this edge, like that. And now this one I can move it like this. So let's start arranging this. Move. 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 Okay, now we are there. We have done the arrangement of the components. So what we need to do is now to draw the edge cut for our components. So you come here, pick this one. Now we go to finalize with the edge cut. Okay, so these were one of our board. So somehow it looks like. Therefore, what I need to do, I want to do an outer routing because of time. So I come here. Okay, I can export DSM spectra NodeMCU like that. Okay, enable, so I'm going to save first. I did not save it. So go to file and then export DSM spectra. Okay, it's unable to export. Let me try to look at why is it unable to export. Control C. Multiple symbols of identical reference IDs of Let's see how it behaves now. File, export, DSN spectra. See, that one is correct. So what we want to do is to go for free routing. Design desktop code. Click go for new. Then ESP. Open. Let's allow it now to free route like that. Then we can do routing. See now the advantage of doing routing. It's a 4-layer board. Let's finish up on the routing. Let's see how it will look like. This is a 4-layer board, so it will take a lot of time when trying to do routing. So let it finish up. Okay. So I'll try to import the spectral session and see what's happening. We have 120 unrooted, so you have to do it by yourself. So at least you can see this is how your board should look like. We can do some copper pulls. Start with this one. Oh, sorry. Start with this one. We click on copper pulls. Go jealous around. Okay. Then you go to the second layer, which is this one. Do the copper port again, is like ground. Okay. Like that. Like that. Like that. Like that. You go to this one. Do it. Select ground. Hit OK. Come here like this, like this, like this, like that. Then you go to the final one. You do the color the same. Okay. Like that, like that, like that. Then you come and view it. Okay, you can see this is something to do with the board. So what you do, you come to change the color. Then you start the color of the mask. You can do the color of the mask. It should be black. These bolts are black in color. Yes. Correct. Yes. So I think this is our board, our NodeMCU board. Okay, as it looks in the market. This is it. This is what is needed of. This marks the end of our video on the design of the ESP8266 NodeMCU board. Thank you for being part of us. My name is Simon. See you next time. Thank you.